All right, so now that we know how to multiply polynomials using algebra tiles, we're going to take a look at multiplying polynomials using the box or array method. So this will look very similar to something that you've done in science probably. Looks very similar to the Punnett square. So if you're familiar with that, this should be very similar to that, should be easy in a way. So when we set these up, basically notice that we have, in this first example, we have a binomial times a binomial. So we know that we're going to want a 2 by 2 box since we have 2 terms times 2 terms. Just like with the algebra tiles, on the outsides, we're going to write the first binomial on the left, or one of the binomials on the left, and the other binomial up top. So the first one, you can see we have x minus 3. So we're going to represent that by x, and then minus 3, or negative 3. In the top, then we'll have x, and then negative 2. So basically each slot can only have one term or one part of that polynomial. And then once we set that up, then we're just going to multiply into those squares on the inside to find our product. So in the first part, we'd be doing x times x, which we get x squared. Since we're multiplying, we're going to add our exponents. Then if I come over here, I have x times negative 2, which would be negative 2x. Come down here, I have negative 3 times x, which is negative 3x. And then in this corner here, we have negative 3 times negative 2, which is a positive 6. Once we do that, we want to identify like terms. When using the box array method, it is often fairly easy to identify like terms because they are typically going to be on diagonals. So here you can see we have negative 3x and negative 2x. Notice that they're on a diagonal, makes it a little bit easier to identify those like terms and then combine them. So we're multiplying to get into the square, then we're combining our like terms, or we're adding to get out. So our final product, we're going to have x squared. When we combine the negative 3 and negative 2x, it gives us negative 5x. And then we have our plus 6. That's going to be the answer to that first product using the box or array method. So this is going to be an alternative to distributing like we had done in a previous notes. This is an alternative way of multiplying polynomials. Once you practice this a little bit, you'll be able to then decide which method you like better. Let's take a look at the second example. So we have 2x plus 1 times x plus 1. Again, we have a binomial times a binomial. So I'm going to set up my 2 by 2 box. On the outside on the left, I have my first binomial, which I have 2x as my first term, and then a positive 1 or plus 1 as my second term. In the second binomial, I have x as my first term, a positive 1 or plus 1 as my second term. Again, we're going to multiply to get inside here. So we have 2x times x, which gives us 2x squared. Then we have 2x times 1, which is 2x. Down here we have 1 times x, which is just 1x or x. And then here we have 1 times 1, which gives us 1. Again, once we multiply in, we want to identify our like terms. In this case, you can see again on the diagonal here, we have 2x and x. And then we'll combine our like terms or add to get out of our square. So we have 2x squared, and we have x and 2x, which gives us 3x, and then 1. So our final product would be 2x squared plus 3x plus 1. All right, I'm going to go ahead and skip ahead to number 5. So I'm going to work through just a couple of these, and I'll have you finish up the other ones as practice. So if we move on to number 5, notice that we're now going to involve 2 variables. So the process will be the same. We're just going to have to look a little bit more carefully when combining like terms. So once again, we have a binomial times a binomial. So we're going to set up our 2 by 2 grid. First term over here on the left, we have 3a, and then negative b or minus b. In the top, we have 2a, and then plus 4b or positive 4b. We multiply in, so 3a times 2a would give us 6a squared. Just watch out for that. That will be a common mistake as you move throughout. Typically with those who didn't get the multiplying rules really quickly, a lot of people will say 6a here instead of a squared because they forget to add those exponents. So just watch out for that. This first term will almost always be different than the other terms over here. All right, looking at our next term, we have 3a times 4b. So multiplying coefficients gives you 12. Since a and b are different variables, we can't combine them. So we're just going to keep that as ab. If I look at my next expression down here, I have negative b times 2a. Multiplying coefficients, negative 1 and 2. I get negative 2. And again, we have two different bases. We have a and b, so we're just going to write that as a, b. The order in which you write the a and the b really doesn't matter. What's important is we do identify that these are like terms. And again, typically we're going to be writing variables in alphabetical order. If I look at my last term, I have negative b times 4b. Multiplying coefficients would give us negative 4. And then b times b, we'd add the exponents to get b squared. So once again, we do have some like terms here on our diagonal. So if I look at then the sum, I have 6a squared. I have negative 2ab plus 12ab, which would give me a positive 10ab. Remember, when adding, your exponents will not change. And then we have negative 4b squared or minus 4b squared. So our final product, 6a squared plus 10ab minus 4b squared. All right, let's skip ahead again. Let's go to number 9. So in number 9, we're going to be taking a look at two binomials where we have only one variable, but we do have higher exponents than what we're used to seeing. So let's take a look at multiplying this. Once again, we do have a binomial times a binomial, so we're going to once again set up our 2 by 2 grid. On the left, we have a squared and 2. Up top, we have a to the 5th and 1. So we'll go ahead and multiply to get in. So a squared times a to the 5th. Remember, we're going to add those exponents to get a to the 7th power. Then we have a squared times 1, which gives us a squared. 2 times a to the 5th would give us 2a to the 5th power. And then 2 times 1 is our last term, would give us 2. Let's go ahead and notice that we don't have any like terms in this case since all of the exponents are different. So as we write out our final product, our final polynomial, we're going to go ahead and write it in standard form, which remember means from the highest degree to the lowest degree. So a to the 7th power would be my first term. Next highest exponent is going to be 5, so I'm going to write that 2a to the 5th next. And then we have a squared and then 2. If you don't write it in standard form, it is not technically wrong, but we like to write it in that form. Number one, it does make it a little bit easier to check because if our terms are all in the same order, it's a lot quicker and easier to see if we have the same answer. Also, again, it's going to become handy once we start getting into some more complex topics later on in the year. All right, so those are all binomials times binomials. This method does work with trinomials as well. So let's go ahead, let's flip over to the back and let's take a look at 2 of those examples. So in the first example, we have a trinomial times a binomial. So since we have 3 terms and then 2 terms, when we set this up, we're going to want a 3 by 2 grid. So I'm going to set it up with 3 rows vertically and then 2 columns. When you have a different number of terms in your polynomials, it does now start to matter which one goes over here and which one goes up here, because this over here obviously has to be the polynomial that has 3 terms. So if I do that, I have 3a squared as my first term, I have b as my second term, and I have negative 4 as my third term in that first trinomial. Up top, I have my second polynomial here, which is b squared, and then minus 2a or negative 2a. Now we're just going to multiply to get in. So we have 3a squared times b squared. Multiplying our coefficients, you get 3. Since we have different bases, we cannot combine those variables at all, so they're just going to stay a squared, b squared. Next, let's go to the right over here. So we have 3a squared times negative 2a. Multiplying your coefficients, you get negative 6. Now we do have the same base, so we can combine them to one base by adding the exponents. So we would get a to the 3rd power, since 2 plus 1 is 3. Down here we have b times b squared, which multiplying coefficients is 1. So then we just need to add the exponents on that common base, and we get b to the 3rd power. Over here, we have b times negative 2a. So we're going to get negative 2 as our coefficient, and then a times b, they're different bases. So we're just going to leave that as ab. Next, we have negative 4 times b squared, which is just negative 4b squared. And then lastly, negative 4 times negative 2a, which is going to be a positive 8a. Once we multiply, we want to go ahead and look for like terms. I'm seeing that we don't have any terms that have the same variables and same bases. I know we do have like a b squared here and a b squared here, but this term also has an a, so obviously we don't consider that a like term. So we just need to go ahead and write out our product then. We're going to do our best to write this in standard form by going from the highest degree to the lowest degree. But again, if you don't have it written in that form, it won't be wrong. So 3a squared b squared minus 6a cubed plus b cubed minus 2ab minus 4b squared plus 8a. Again, no like terms, so this 6-term polynomial will be our simplified answer, our simplified product. Some of you might be wondering why I wrote this ab before the b squared. Really, it was kind of just a preference. So they both have a degree of 2. I know that these don't have exponents, but remember, the degree of the monomial we get by adding those exponents together. So 1 plus 1 would give us 2. Both have a degree of 2. This one has an a, which comes first alphabetically, so I chose to write that first. If you had them swapped, again, not going to be wrong. All right, so let's move on down to number 13. Let's take a look at our final example, which is the most difficult type of problem that we will encounter, which is a trinomial times a trinomial. Maybe I'm going to walk you through the more complicated of those two examples. I left number 12 for you to practice on your own, which is a little bit easier because of only having one variable there. So let's take a look. Since we have a trinomial times a trinomial, we're going to have 3 terms times 3 terms. So we need a 3 by 3 box. All right, as we look at that, let's write our first polynomial over here on the left. So we have 2x squared, we have 5xy, and then 3y squared. Up top, we have 8x plus xy minus 7y. All right, let's go ahead and start multiplying in. So we have 2x squared times 8x, which is 16x cubed. Next, we have 2x squared times xy, which is 2x cubed y. 2x squared times negative 7y would be negative 14x squared y. Next row, 5xy times 8x would be 40x squared y. Next, we have 5xy times xy, so 5x squared y squared. Then 5xy times negative 7y would give us negative 35xy squared. Last row, we have 3y squared times 8x, which would be 24xy squared. 3y squared times xy would be 3xy cubed. And then we have 3y squared times negative 7y, which would give us negative 21y cubed. All right, so now we're going to go ahead and look for like terms. So remember, we're looking for same variables and same exponents. So looks like we actually have 2 in this case. So I see one pair of like terms right here, which is x squared y. And then I see another set of like terms here, which is xy squared. As I look through the remaining terms, we either have different variables or different exponents. So those are all like terms. So we're going to go ahead and start writing out our final product. So I'm going to write this from highest degree to lowest degree. So I'll start with all the degree of 4 terms first, and then we'll move to the degree of 3 terms. So 2x cubed y, 5x squared y squared, 3xy cubed. Those are my 3 terms that have a degree of 4. Let's move on to the degree of 3. So I have 16x cubed. If I combine the negative 14x squared y and the 40x squared y, I get 26x squared y. If I combine the negative 35xy squared and then 24xy squared, I get negative 11xy squared. And then my last term, I'm running out of room. I'll just write it below. You have negative 21y cubed. So believe it or not, that is our final simplified product. Some of these will get very complex. Some of them will be very long, very messy. All the more reason why I stress the importance of understanding your multiplying monomial rules. If any one of these individual terms in here, you made a mistake, obviously your final product is going to be wrong, is going to be off. So it's really, really, really important that you practice those and have those mastered. Also, really, really important that you are showing your work. If you're not showing your work neatly and clearly, it's going to be very hard to identify where you made a mistake. All right, so I walked you through some of each type. Hopefully you have a fairly good understanding of how to multiply using the box or array method. At this time, go ahead and finish off those last couple of examples as practice. Thanks. Have a great day.